So this is the data analysis for Ichthyoplanktton. There is a total of 5 individuals that we caught, and then there is 2 species which is categorized in the Clupidae family and Ambacidae family. The Clupidae family, as we can see from the graph here, the total is 4, and then from the Ambacidae family, the total individual that we got is 1, and the sampling time is both the same, 11:03 a.m. And then for the length of the Ichthyoplanktton, the first two picture here from the above to the bottom, respectively 11.01 millimeters and 13.54 millimeters. The second picture, the middle one here, we can see 10.66 millimeters and 10.82 millimeters respectively from right to left. And then the right one, the right picture, which is the total length for the Ambacidae family, is 4.32 millimeters.
I'm going to explain about the crabbing method and the data analysis we got from the result. This is the crabbing method for checking the carapace width of the crab. While this is the method for checking the carapace length for the crab. So this is the result we got after identifying the crab. As we can see here, we got 2 crabs. The species name for the crab is Horn-Igos crab, and the scientific name is Uciped seraphthalmus, and the handedness is their right hand. For both crabs, their sex is male, and for body size, the carapace length for the first crab is 31.92 mm, and the carapace width is 35.46 mm. For the second crab, the carapace length is 35.65 mm, and the carapace width is 32.40 mm. Based on the data, we can see that the carapace length for the first crab is shorter than the second crab, while the carapace width is wider than the second crab. Hence, we can see there is no actually big difference between the 2 crabs. There are actually no big problem faced during the crabbing methods, but one of the problems we face during the crabbing is there are several unwanted species of crab trapped in the bait we set up, such as hermit crabs.
Here are the data for the species that we got and the number of individuals of each species, mean standard length, mean total length, mean fork length, and the mean weight. Got was flounder, trevally, shrimp scat, silver tripod fish, half smooth golden pufferfish, ponyfish, stingray, and mantis shrimp. Here is the proof of what we got in the bucket. in the basket.
So this is our result, as you can see, and the time when we did the sampling was 7:30 in the morning. So there are 3 attempts that we took during the field trip, and all of them have different readings. Next, here's the graph according to the result. Next is 4 questions. B. Explain the relationship among parameters that may influence each other. Dissolved oxygen in water is crucial for aquatic life, and factors like temperature, salinity, turbidity, pH, and water clarity that can affect oxygen levels and ecosystem health. High temperature can decrease oxygen solubility, increase metabolic rates, and lead to oxygen depletion. Salinity affects water density, affecting the distribution of aquatic organisms and their metabolic processes. Water clarity, measured by SHIDs, can also be affected by turbidity, temperature, and depth. And for C, how tides, sea or weather condition, and biological processes influence the parameter. Tides that affect water depth, salinity mixing, and sedimentary suspension, impacting parameters like temperature, turbidity, and dissolved oxygen levels. Meanwhile, for sea weather condition, storms can alter temperature, increase turbidity through sedimentary suspension, and affect dissolved oxygen levels due to oxygen exchange and nutrient influx from rainfall. Lastly, for biological processes, photosynthesis and respiration influence oxygen levels and pH, while natural cycling and species interaction affect turbidity and overall ecosystem dynamics. For TSS, the final weight is 1.273 gram and the initial weight is 1.1302 gram. Then we subtract both of these values and we will get 0.1428 gram. For BOD5, the initial DO reading was 6.5 and the day 5 of DO reading is 5.87 milligram per liter. Then we subtract both of these value and we get 0.53 milligram per liter for the BOD5 readings.
For all tide zone, which is low, middle, and high zone, the bentos found in this zone are accombinacles, while for spray zone there is no bentos found. For tide zone, the number of barnacles per replicate for low is 72 and 74, while the percentage cover is 42.67%. For middle zone, number of barnacles per replicate is 60 and 68. The percentage cover is 32.67%. For high zone, the number of barnacles per replicate is 45 and 56. The percentage cover is 34.67. For epibenthos on rock surface facing the land, the benthos found in low and middle zone is also accombinacles, while there is no benthos found in high and spray zone. Number of barnacles per replicate for low tide zone is 32 and 28, and the percentage cover is 12.00%. While for the middle tide zone, the number of barnacles per replicate is 25 and 24, which is 4.00%. While for high and spray zone, there is no number of barnacles found.
These are the macrobenthos overview to summarize all of the sediments that we have collected during the sampling. We managed to get hermit crab and gastropods group for all of our sediments from quadrant 4 until quadrant 10, and the total number of individuals are 38 individuals.
These are the data analysis of the sediments that we have collected. From here, we can conclude that the sediments in Pantai Pandan Lundu is almost entirely sand, as the portion of silt and clay is insignificant. So the formula for silt content is pen over total times 100, and the formula for percentage of loss is 100 minus total over initial times 100. From this bar chart, we can see that the size of the sand fraction decreases over the quadrant as the closer we get to the shoreline. The first question is, what is your opinion on the preferences of sediment grain size by the dominant macrobenthos? Explain. Based on the data we have collected, the dominant macrobenthos was found in quadrant 6, whereby the sands are mostly fine-grained sediments. Macrobenthos prefer this type of sediments because it will be easier for them to burrow into, providing shelter and protection from predator. Next, which zone has bigger size specimen? Explain. The intertidal zone typically has larger specimens compared to the supralittoral zone. This zone is regularly submerged and exposed due to tides, providing a dynamic and nutrient-rich environment. It supports a diverse array of organisms, including a larger species such as sea stars, crabs, anemones, mussels, and various types of seaweed. While supralittoral zone, also known as the splash or spray zone, this area is only occasionally wet by waves and is primarily a harsh, dry environment. Organisms here must be highly adapted to withstand desiccation and temperature extremes.